Hello everyone, this is Dr. Alok Agrawal and I will be taking in this video a very important topic of internal combustion engine, which is of fifth semester mechanical branch, that is power and efficiency of IC engine, that is internal combustion engine. So let us first see the first law analysis of engine. So what is happening that we know that in thermodynamics first law what it say that energy can neither be created nor be destroyed, but it can be converted from one form to another. So we are applying this first law of thermodynamics into our engine. So what is happening? See that there should be an energy balance between input and output of the system. So whatever energy is coming, it need to be properly distributed for output. So we are seeing here that only. So first, when in SI engine, fuel is fed inside the combustion chamber, and when it is burned, it converts, it release energy. That is, burning of fuel release energy. How it is releasing energy? Here, the chemical energy of fuel is converted into thermal energy, and that thermal energy is utilized to do some useful work in IC engine. So what we are getting output? We are getting heat as our output. Now, this liberated energy, which is in the form of thermal energy or heat, is not totally utilized for driving the piston or for driving the vehicle. Some part of energy get utilized somewhere else, and finally we get very small part of energy which is utilized to drive a vehicle. So let us see this energy. So first one is indicated power. See what is happening when the fuel burns and it produces energy. There is a loss of energy. That complete energy is not available in the piston, so the piston will move. What are the sources which takes energy from the burning fuel? The first one is the engine exhaust. We have seen that there is some thermal energy associated with exhaust gases. It means that complete thermal energy is not getting utilized to do some useful mechanical work. So that is a part of energy that is going wasted with exhaust gas. Again, some thermal energy is taken by the coolant, which is just surrounding over the cylinder. And another loss of energy during the combustion is radiation, because every body which has temperature greater than zero will radiate heat energy. So these are the three major part where the energy obtained after the combustion will be utilized or will be wasted, like exhaust gases, coolant, and radiation. After that, whatever energy left, this energy is known as indicated power, and this power will be transferred into the piston, or this energy will be utilized to drive the piston. So there is a after releasing thermal energy, fuel will utilize that energy. That energy will be utilized somewhere else, that is in engine exhaust, in cooling, and in radiation. The remaining energy will be utilized by the piston so that it will move. The energy available at the piston top is called indicated power. Now, after that, once the energy is transferred into the piston, again that energy is not completely converted into the output, and it will be useful for driving the engine. There are some other losses also, which is mainly because of the friction. Because when the energy is received in the piston, what is happening? The piston transfer its energy to crank with the help of connecting rod. During this transmission, there are losses of energy because of friction, bearing friction and pumping loss. Apart from that, there are also some energy utilized to drive other components of the engine like feed pump, valve mechanism, ignition system, and many other things. After deducting all such losses, means after using the available energy of the piston, after utilizing all this energy, the remaining energy will be the output. Means if indicated power fuel, first fuel will burn and produce thermal energy. In that thermal energy, some part of energy is going through exhaust gas, cooling system, and radiation. The energy available at the piston top is known as indicated power. Once the energy is transferred into the piston top, again a part of energy is utilized to do some other work like to overcome the friction, to drive the auxiliary system like feed pump, valve mechanism. And after that, the available energy, which is useful for doing mechanical work or which is useful for driving our vehicle, is called brake power. So there are two important power, that is indicated power and brake power. And the difference between, and here it is necessary to know that indicated power will always be greater than brake power. And the difference of these two power is called frictional power. That is, indicated power minus brake power is called frictional. So these are the three types of power that are associated with engine, IC engine. That is indicated power, brake power, and friction power. Now let us move with the efficiency. So first one is thermal efficiency. So what is thermal efficiency? Thermal efficiency is, it determines how effectively the fuel is utilized inside the engine. Means how effectively, when the fuel will burn, how effectively we can utilize the thermal energy produced by the fuel. So there are two types of thermal energy. First is indicated thermal efficiency, and the second one is brake thermal efficiency. So what is indicated thermal efficiency? It is associated with indicated power, and brake thermal efficiency is associated with brake power. So in indicated thermal efficiency, it is the ratio of indicated power to the energy supplied by the fuel, that is called fuel energy. So how we can define it? We can define it mathematically as a ratio of indicated power divided by mass of fuel burn into the calorific value of the fuel. See, MF is the mass of fuel burn per cycle, and Q is the calorific value of the fuel. Means how much energy is released by the fuel when a certain amount of fuel is burned. 1 kg of fuel is burned, so it will produce some X amount of energy. So if MF amount of fuel will burn, it will be supplied that much energy, which is multiplied by the mass of fuel burned multiplied by its calorific value. So this is the indicated thermal efficiency of the engine. Similarly, brake thermal efficiency is the ratio of brake power to the fuel energy. So what is happening here? Only the indicated one, numerator part, indicated power is replaced by brake power. The denominator part will remain the same. So it is the ratio of brake power to the mass into calorific value of the fuel. So this is two types of thermal energy, which is very important. Next is mechanical efficiency. See, mechanical efficiency is the ratio of brake power to indicated power. Mechanical efficiency defines what are the various mechanical losses happening inside the engine. So where is the mechanical losses are taking place? During the transmission of power from piston to the output, means to the crankshaft. So what are the various losses happening because of friction, because of power taken to run the auxiliary part like this? So it is the ratio of brake power to the indicated power. Again, this indicated power can be replaced by brake power plus friction power, just we have seen. So again, mechanical efficiency is brake power upon brake power by frictional power. Now, if we'll see it, if we'll visualize it, we can make a relation between the three efficiencies, that is indicator thermal efficiency, brake thermal efficiency, and mechanical efficiency. Because mechanical efficiency is the ratio of brake power upon indicated power. So we can write here brake thermal efficiency and indicator thermal efficiency, because denominator is same and it will be cancelled out. So this is a very important relationship between the three efficiency. If we know two efficiencies, we can easily evaluate the third one with the ratio, that is mechanical efficiency is equal to the ratio of brake thermal efficiency and indicator thermal efficiency. So this relation is very important and will be utilized in numerical sometimes. So these are the two types of efficiency. Next one is volumetric efficiency. So what is volumetric efficiency? It is actually the amount of charge actually taken inside the combustion chamber to the maximum amount of charge that can be taken. So it is a ratio of two volumes. The first, in numerator, it will be the amount of actual amount of charge that is taken inside the combustion chamber during the suction stroke, and in denominator it will be the maximum amount of charge that an engine can take during the suction stroke. Okay. Volumetric is also an indication of breathing ability of the engine, where the maximum amount of charge that is taken inside the that can be taken inside the combustion chamber is its swept volume. When piston moves from top dead center to bottom dead center, the maximum volume swept is swept volume, and that is the maximum amount volume of charge that an engine can take. But actually, it will not take that amount. It will always take a little bit less amount of charge uh, is maximum efficiency. So it will be volumetric efficiency will always be less than 100%. So it is the ratio of volume of charge actually taken to the maximum amount of charge taken, which is always a swept volume of an engine. This is the volumetric efficiency. Volumetric efficiency varies between 95 to 99%. Okay. Next and last one is relative efficiency. So it is the ratio of thermal efficiency of actual engine to the thermal efficiency of ideal engine. See, we have seen auto cycle, we have seen diesel cycle, dual cycle. If the engine, SI engine, we are talking about auto cycle. So the maximum efficiency of auto cycle is 1 minus 1 upon R to the power gamma minus 1. So this is the maximum thermal efficiency when the cycle or the engine works at ideal cycle. But in actual, it is not the case. In actual, the engine will not follow exactly auto cycle. Why? Because auto cycle is an ideal cycle. It is designed for SI engine to give maximum efficiency, which is 1 minus 1 upon R to the power or compression ratio to the power gamma minus 1. But the efficiency, actual engine efficiency is always less than 1. So relative efficiency is the ratio of actual efficiency of an engine to the efficiency of ideal engine. If we will talk about SI engine, it will be efficiency of auto cycle, and if we will talk about diesel engine, it will be a efficiency of diesel cycle. So these are the four efficiencies which are associated with IC engine, that is thermal efficiency, mechanical efficiency, volumetric efficiency, and relative efficiency. So in this video, this is all. Thank you. Thank you very much.